The sky is ablaze, not with fire, but with countless streaks of light plummeting toward the horizon, each one a blazing arrow piercing the darkness, exploding in silent fury, as if the heavens themselves are unraveling. People scream in terror, falling to their knees, convinced the end of the world has arrived, the stars literally crashing down upon humanity in a divine reckoning. This is not some distant nightmare from ancient prophecy. This happened on the night of November 12th to 13th, 1833, during the Leonid meteor storm, when witnesses across North America reported seeing tens of thousands of meteors per hour. A spectacle so overwhelming that it sparked mass hysteria, religious revivals, and fears of apocalyptic doom. Newspapers of the time described it as the day the stars fell, with accounts of entire communities gripped by panic, believing Judgment Day was at hand. But what if that storm was no mere cosmic coincidence? What if it was a harbinger, a deliberate signal from beyond our world, masked as natural chaos to test our reactions, our fears, our readiness? Now, fast forward to today, September 6th, 2025, and consider this. An interstellar object named 3I Atlas is hurtling through our solar system at speeds defying easy explanation, its path eerily precise, brushing close to planets in ways that astronomers whisper could not be random. Harvard astrophysicist Avi Loeb, a voice daring to challenge the status quo, has publicly speculated that this visitor might not be a simple comet or asteroid at all. In his writings and interviews, Loeb points to anomalies, its retrograde orbit almost perfectly aligned with our solar system's ecliptic plane, a statistical improbability of less than 0.2%. It swings perilously near Venus, Mars, and Jupiter, with odds of such alignments at a mere 0.005%. No clear outgassing like typical comets, yet a faint, fuzzy appearance that hints at something more. And crucially, as it approaches its closest point to the Sun on October 30th, 2025, it vanishes from our view, hidden behind the star's glare, a perfect blind spot for maneuvers unseen. Loeb asks, could this be a mothership, deploying invisible mini-probes ahead of it, scouting our world without detection? He warns that if it zigzags, nears Earth unexpectedly, or releases smaller craft, the stock market could crash in panic, societies could fracture. But why the silence from global leaders? Is this object a probe from an advanced civilization, silently observing us, or something far more ominous? Delve deeper into the shadows of history, and patterns emerge that chill the soul. The 1833 Leonid storm was not just a light show. It transformed science itself. Before that night, meteors were dismissed as atmospheric illusions or omens from gods. After, astronomers like Dennis and Olmsted crowdsourced reports from newspapers, pinpointing the radiant in the constellation Leo, birthing modern meteor astronomy. Yet, whispers persisted. Why did it coincide with rising tensions, sparking religious fervor and doomsday cults? Accounts from enslaved people in the American South saw it as a sign of liberation, while others feared biblical Armageddon. Was it truly random, or a calculated event, engineered to influence human evolution, to push us toward understanding the cosmos, or to warn us of watchers from afar? Consider the VASCO project, the vanishing and appearing sources during a century of observations, an international effort scanning historical sky surveys against modern ones, hunting for stars that have inexplicably disappeared. Since 2017, led by Beatriz Villarroel, it has uncovered anomalies, objects present in 1950s military catalogues, gone today. Citizen scientists worldwide pore over images, finding transients that defy explanation, stars vanishing without trace, perhaps swallowed by black holes, or something artificial. But conspiracy theorists link it to Cold War secrets. The VASCO findings echo reports of vanishing stars from the 1940s, possibly concealed orbital grids predating Sputnik, hidden by governments fearing public panic. What if these disappearing lights are not natural? What if they signal advanced civilizations harvesting energy, building Dyson spheres, or worse, erasing evidence of their presence? VASCO's offshoot for kids, Virginia SCO Kids, engages young minds, but the implications are profound. Are we alone, or are we being edited out of the cosmic record? Avi Loeb's theories on 3i Atlas amplify these enigmas. In his Medium posts and papers from July and August 2025, he argues we should not dismiss the artificial hypothesis lightly. With a 40% chance of accident in crossing paths with such an object, he says, we must keep our eyes open. He compares it to Oumuamua, the first interstellar visitor in 2017, whose bizarre acceleration without visible coma led to hydrogen outgassing theories, or more speculatively, solar sails from alien tech. Loeb's Galileo project scans for technosignatures, and for 3i Atlas, he notes its size around 20 kilometers if an asteroid with low albedo far larger than expected, its composition rich in carbon dioxide but water poor, defying solar system norms. In a YouTube debate on August 23, 2025, critics like those in Why Avi Loeb is Wrong About 3i Atlas counter that it's a natural comet, but Loeb persists. The blind date with Mars on October 3rd could deposit materials, signatures of technology, if analyzed. Social media buzzes with X posts from users like UAP Reporting Center, quoting Loeb, "If I saw 3i Atlas zigzagging, nearing Earth, or deploying mini probes, the stock market may crash." Others speculate it's a fleet, with precursors already here. Silent observers. These ideas intertwine with ancient mysteries, like the Dogon tribe's knowledge of Sirius B, an invisible white dwarf, passed down through myths of amphibious beings from the stars. Vedic texts speak of Vimanas, flying craft from other worlds, while Sumerian lore describes Apkallu, fish-like sages emerging after floods to impart wisdom. Could 3i Atlas be a modern echo, a probe from those same origins? The Younger Dryas impact theory posits a comet strike 12,000 years ago ended civilizations like Atlantis, described in Plato's accounts as advanced societies sunk by catastrophe. Was that a natural event, or a deliberate reset by extraterrestrial forces? The 1811 comet coincided with the New Madrid earthquakes, devastating the Midwest. Coincidence or cosmic interference? On X, semantic searches reveal a torrent of theories since July 2025. Posts claiming 3i Atlas's nickel emissions without iron suggest industrial alloys, electroplated shells impossible in nature. One user ties it to cyanide plumes, hallmarks of manufacturing. Another warns of artificial signatures, a reconnaissance mission mapping habitable worlds. Keyword searches for 3i Atlas, alien conspiracy, or Loeb, or mothership yield latest discussions. A podcast host speculates it's from Talpiot, Israeli military intelligence, blending human and alien tech. Dark journalist videos allege Loeb's background in Star Wars programs masks deeper agendas. Skeptics like Michael Shermer debate Loeb live, citing planetary scientist Alan Stern. It's a natural interstellar comet, ejected from another system, no closer than 20 million miles to Mars. Yet, questions linger without answers. If vanishing stars in VASCO are real, who or what erases them? Why does 3i Atlas's path flirt with our planets, as if probing defenses? Is the Leonid Storm's legacy a clue, a historical test of humanity's resilience? What if mini-probes are already here, invisible, relaying data back to a distant home? These enigmas pull at the threads of reality, suggesting we're not alone, but watched, perhaps judged. The universe whispers secrets, but are we ready to hear? As these cosmic riddles unfold, allow me to introduce myself properly. I am Zen, your serene guide through the vast mysteries of the universe. Here on Cosmic Mysteries for Sleep, together, we drift into the unknown, exploring the whispers of stars and the echoes of eternity to lull your mind into peaceful wonder. If these tales ignite your curiosity, consider subscribing to the channel and turning on notifications. It's a gentle way to ensure you never miss the next journey into the cosmos, where secrets await in the quiet of the night. In the vast tapestry of human history, comets have long been viewed not merely as celestial wanderers, but as divine messengers, carrying secrets from the stars, often heralding profound changes or cataclysms on Earth. Across ancient cultures, these fiery visitors were interpreted as omens, guides, or even vehicles for otherworldly beings, weaving threads of mystery that connect distant civilizations to our modern curiosities about objects like Three-Eye Atlas. Let us delve into these enigmatic tales, starting with the Dogon people of Mali, whose astronomical knowledge challenges everything we assume about primitive societies and their grasp of the cosmos. The Dogon, an isolated tribe in West Africa, have preserved oral traditions that speak of advanced stellar wisdom imparted by extraterrestrial visitors known as the Nomo. These beings, described as amphibious, fish-like creatures with human characteristics, are said to have descended from the Sirius star system in a craft that splashed down amid thunder and flame. According to Dogon lore, the Nomo emerged from watery depths, bringing knowledge of agriculture, language, mathematics, and the stars. They taught the Dogon about Sirius B, a white dwarf star invisible to the naked eye, which they call Po Tolo, noting its 50-year orbit around Sirius A, and its extreme density heavier than all the iron on Earth. Remarkably, this information predates modern telescopes, as Western astronomers only confirmed Sirius B in 1862. The Dogon even hint at a third star, Sirius C, still debated in contemporary astrophysics, which they claim played a role in their cosmic understanding, linking their ancestors to an ancient extraterrestrial lineage. What makes this particularly intriguing is how the Nomo narratives intersect with global myths of water-sky beings appearing after cataclysms to uplift humanity. The Dogon depict these visitors in their art as hermaphroditic spirits, with green skin and serpent-like lower bodies, symbols of duality and balance. Their arrival is tied to creation stories, where the Nomo restore order. Much like modern reports of unidentified flying object encounters or alien abductions, French anthropologists Marcel Grial and Germaine Dieterlen, who studied the Dogon from 1931 to 1956, documented these beliefs through extensive conversations, including a 33-day dialogue with Elder Ogo Temli. Yet, debates rage. Skeptics like Wouter van Beek argue this knowledge might stem from 20th century European influences, perhaps from astronomers during an 1893 solar eclipse expedition. Others, including Robert Temple in his 1976 book The Sirius Mystery, propose ancient extraterrestrial contact, suggesting the Nomo were real beings from Sirius who shared forbidden insights. This theme of stellar messengers echoes in Sumerian lore, where similar fish-like sages called the Apkallu emerge from the primordial waters of the Abzu to bestow civilization upon humanity. The first and most prominent, Oannes, also known as Uana or Adapa, is portrayed as a being with the body of a fish, a man's head beneath its fish head, and human feet under its tail. According to Babylonian priest Borisov, writing in the 3rd century before the Common Era, Oannes rose from the Persian Gulf in the 1st year of creation, teaching humankind, writing, arts, sciences, and the foundations of society. He spoke with an articulate human voice and returned to the sea at night, only to reappear the next day. Representations of Oannes and the Apkallu, often as 7 sages, appear in Assyrian palaces as guardians against evil, with fish-skin cloaks or bird-headed forms. Sumerian texts, inscribed on cuneiform tablets from the library of Ashurbanipal, describe the Apkallu as demigods created by the god Enki to advise early kings before the Great Flood. They are not gods themselves, but experts in wisdom, serving as priests, exorcists, and diviners. The Epic of Gilgamesh mentions them as counselors, who founded cities like Uruk. Some scholars equate them with the biblical Nephilim or fallen angels, noting their transgressions that angered the gods, leading to their banishment back to the Abzu. Conspiracy theorists link the Apkallu to extraterrestrial theories, suggesting they were advanced visitors posing as sages, much like Zecharia Sitchin's interpretation of the Anunnaki as alien engineers who genetically modified humans. Critics dismiss this as pseudo-archaeology, arguing Sitchin mistranslated Sumerian words and truncated quotes. Still, the consistency across cultures fish-like teachers emerging post-flood raises questions. Were these comets or their impacts seen as portals for such beings? Shifting to the Vedic traditions of ancient India, comets take on roles as celestial messengers or even vehicles from the stars, intertwined with flying craft known as vimanas. In the Rig Veda and Mahabharata, vimanas are described as self-moving aerial chariots, sometimes serving as thrones for gods or palaces 7 stories high. The Pushpaka Vimana, stolen by Ravana in the Ramayana, could traverse vast distances at the speed of thought, radiating light and rumbling deeply. These machines, powered by elements like mercury or unknown substances resembling honey, could become invisible, change shape, or unleash destructive weapons. Sage Maharshi Bharadwaj's Yantra Sarvasva details their construction, hinting at mercury propulsion systems akin to modern ion engines, where heated mercury creates thrust. Vedic texts portray comets as Ketu or Dhumaketu, smoky banners or fiery tails, often as omens from the gods or messengers heralding change. The Atharva Veda invokes protection from comets like Dhumaketu, associating them with divine fire. Some interpretations link vimanas to comets, suggesting these flying palaces were inspired by comet sightings, viewed as starry chariots carrying divine entities. Conspiracy theories propose vimanas were actual extraterrestrial craft, with descriptions matching unidentified flying objects, saucer-shaped with portholes and domes. Eric von Daniken argues modern unidentified flying object sightings resemble ancient vimanas, possibly explaining why Vedic gods like Indra wield thunderbolts from aerial vehicles. Could comets have been mistaken for these messengers? Or were they harbingers of interstellar visitors? These ancient perceptions gain eerie relevance when examining historical comets tied to earthly disasters. Like the Great Comet of 1811, visible for a record 260 days, and coinciding with the devastating New Madrid earthquakes. From December 1811 to March 1812, massive tremors reshaped the Mississippi River Valley, creating lakes and reversing river flow. Witnesses described fiery skies and comet-like apparitions, fueling theories of cosmic causation. Some speculate the comet's gravitational pull or electromagnetic effects triggered seismic activity, echoing Vedic views of comets as disruptive messengers. This pattern culminates in the Younger Dryas impact hypothesis, proposing a comet fragmented and exploded over North America around 12,900 years ago, sparking abrupt cooling, megafaunal extinctions, and cultural shifts. Evidence includes nanodiamonds, microspherules, and platinum spikes in sediment layers, suggesting widespread fires and an impact winter. Proponents like the Comet Research Group link this to black mass organic rich soils at 50 sites, indicating biomass burning across continents. Critics argue these markers result from terrestrial processes, not a cosmic event, with non-reproducible evidence and flawed methodologies. Yet, the hypothesis connects to ancient legends, including Plato's Atlantis, described as sinking in a cataclysmic flood 9,000 years before his time, aligning roughly with the Younger Dryas. Graham Hancock's Magicians of the Gods suggests the impact obliterated advanced Ice Age civilizations, inspiring global flood myths like Noah's Ark or Sumerian deluge tales. In Vedic lore, similar cataclysms reset humanity, with Vimanas as survival craft for gods or sages. 3I Atlas, discovered on July 1st, 2025, mirrors these ancient enigmas with its hyperbolic orbit eccentricity, approximately 6.1, suggesting origins from the galaxy's thick disk, a relic from 3 to 11 billion years ago. Its carbon dioxide dominance and distant activity at 6.4 astronomical units evoke hypervolatile messengers, perhaps echoing comet impacts or extraterrestrial probes. Discussions speculate it's a celestial oracle, pulsing signals like ancient star myths, Sumerian omens of Enlil, Greek prophecies of Apollo, Navajo ancestral trails. Some posts envision it as a 7-mile comet, weaving cosmic codexes, transmuting into blockchain art of interstellar species. Could 3I Atlas be a modern Apkallu or Nommo vessel, probing our world as ancient visitors did? These connections provoke endless wonder. Were comets mere harbingers, or portals for advanced beings reshaping history? Did the Younger Dryas comet doom Atlantis, scattering survivors to seed Dogon, Sumerian, and Vedic wisdom? As 3I Atlas hurtles toward its Mars-flyby on October 3rd, 2025, one ponders if it's a tattered remnant from galactic wars, a probe scouting habitable realms, or simply a natural wanderer. The universe teases with patterns too coherent for coincidence, leaving us to question, what forgotten truths do these starry messengers conceal? As we pause in this exploration of ancient cosmic whispers, I find myself curious about you, dear listener. Where in the world are you tuning in from tonight? And what time is it there as these mysteries unfold in your ears? Picture this: a quiet night in the Chilean Andes, where the stars hang so low you could almost touch them, and a telescope array scans the heavens relentlessly, hunting for threats that might one day collide with our fragile world. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System Survey in Chile captures something extraordinary. A faint streak of light moving at an astonishing 58 kilometers per second, not orbiting our sun like everything else in the solar system, but slicing through on a path that screams origins from another star. This is no ordinary find. It is 3I Atlas, the third confirmed interstellar object to grace our cosmic neighborhood, and its arrival ignites a firestorm of questions that astronomers worldwide scramble to answer before it vanishes forever into the void. The discovery unfolds in real time, with initial observations pouring in from the Asteroid Terrestrial Impact Last Alert System telescopes, revealing an object hurtling inward from beyond Jupiter's orbit. At first, it appears as a dim point, magnitude around 20, barely distinguishable from the background stars, but its velocity sets off alarms. Objects from our own system move predictably, bound by the sun's gravity, but this one's trajectory is hyperbolic, with an eccentricity of approximately 6.1, far exceeding 1, the threshold for closed orbits. This mathematical signature alone marks it as an outsider, carrying the gravitational echoes of a distant star, perhaps ejected billions of years ago from a chaotic planetary system light years away. Astronomers at the Minor Planet Center quickly confirm this is interstellar, designated 3I/Atlas or Comet C/2025, N1 parenthesis Atlas parenthesis. What makes this moment historic is not just the rarity, only 2 such visitors before, 1I/Oumuamua in 2017 and 2I/Borisov in 2019, but the timing. Detected at about 4.5 astronomical units from the Sun, farther out than Mars. It gives scientists a precious window of months to study it before its closest approach, or perihelion, on October 30th, 2025. At roughly 1.4 astronomical units. Even more tantalizing, its path promises a spectacular flyby of Mars on October 3rd, passing within 30 million kilometers of the red planet, close enough for detailed scrutiny by orbiters like those from the European Space Agency and the National Aeronautics and Space Administration, yet safely distant from Earth, posing absolutely no collision risk. But in the whispers of online forums and scientific chats, some wonder, is that distance deliberate? A calculated observation point for something more intelligent than ice and rock? Follow-up observations flood in rapidly. Within hours, amateur and professional astronomers alike swing their instruments skyward. The Zwicky Transient Facility at Palomar Observatory digs into its archives, uncovering pre-discovery sightings from June 14th to 29th, 2025, confirming the object's inbound rush. The Asteroid Terrestrial Impact Last Alert System itself reveals earlier glimpses from June 5th onward, hidden amid the dense star fields near the galactic center, where the comet's faint glow blended into the cosmic crowd. By July 2nd, reports from the Deep Random Survey in Chile, the Lowell Discovery Telescope in Arizona, and the Canada-France-Hawaii Telescope on Mauna Kea all note a subtle coma, a hazy envelope of dust and gas, stretching perhaps 3 arc-seconds, hinting at a tail-like extension. This activity, so early and at such a distance, puzzles experts. Typical water ice does not sublimate until closer to the Sun, around 3 astronomical units. Yet here is evidence of outgassing, suggesting hypervolatiles like carbon monoxide or carbon dioxide at play. Digging deeper into the archives, NASA's Transiting Exoplanet Survey satellite data from May 7th to June 2nd, 2025, yields a bombshell. The comet was already active at 6.4 astronomical units, well beyond Jupiter, with a brightness consistent with its July magnitude, implying steady outgassing over months. Researchers Adina Feinstein, John Noonan, and Daryl Seligman employ shift and stack techniques to align images along the predicted path, boosting the signal and revealing a comet that defies expectations. At such frigid distances, water remains frozen solid. So what drives this distant activity? Hypervolatiles, perhaps, sublimating at lower temperatures, or something more exotic subsurface gas pockets, cosmic ray processing during its interstellar voyage, or, as some daringly speculate, an internal energy source, not of natural origin. This precovery extends the observational baseline, refining the orbit and hinting at the comet's size. Estimates range from 1 to 10 kilometers in diameter, though Hubble's later views peg an upper limit of 5.6 kilometers, potentially as small as 440 meters. The coma, elliptical and spanning up to 26,400, by 24,700 kilometers twice Earth's diameter suggests a nucleus losing material at a kilogram per second, a modest but sustained erosion that could strip millions of kilograms by perihelion. Yet, no tails or jets appear in early images, and the nucleus remains unresolved, blurred within its dusty shroud. The intrigue deepens with comparisons to predecessors. One Eye/Oumuamua, spotted post-perihelion in 2017, showed bizarre non-gravitational acceleration without a visible coma, sparking debates over hydrogen outgassing, nitrogen ice, or even artificial solar sails, as Harvard's Avi Loeb boldly proposed. 2I/Borisov, discovered in 2019, behaved like a classic comet, rich in carbon monoxide higher than solar system norms, developing a tail as it neared the Sunday. 3I Atlas seems a hybrid, active like Borisov but enigmatic like Oumuamua, its dust-dominated spectra hiding gas signatures that telescopes strain to detect. Conspiracy theories erupt across social media platforms like X, where semantic searches for 3I Atlas alien conspiracy or mothership speculations uncover a whirlwind of speculation. Users point to the comet's retrograde orbit, inclined 175 degrees, as too precise for chance, with a statistical improbability of 0.2% alignment with our ecliptic plane. Loeb's Medium post from July 12, 2025, highlights preliminary anomalies, a size potentially 20 kilometers, if asteroid-like with low albedo, and a path flirting with Venus, Mars, and Jupiter, at odds of 0.005%. He questions the lack of clear outgassing yet fuzzy appearance, suggesting a mothership deploying invisible probes, especially as it ducks behind the sun's glare at perihelion, a perfect cover for unseen maneuvers. X posts buzz with claims. One ties nickel emissions without iron to industrial alloys, impossible in nature. Another speculates cyanide plumes as manufacturing hallmarks. Podcast hosts invoke Talpiot, Israeli military programs blending human and alien tech, while dark journalist videos allege Loeb's Star Wars background masks agendas. Skeptics counter, citing planetary scientists like Alan Stern. It is a natural comet ejected from another system, no closer than 20 million miles to Mars. Yet, the blind date with Mars fuels fears. Could it deposit materials, technosignatures if analyzed, biblical echoes add layers, comets as signs of disaster in ancient texts, like the Star of Bethlehem or Revelation's wormwood poisoning waters? The Book of Joel describes skies darkening with fiery trails, omens of judgment. In 2025, some see 3I Atlas as a modern wormwood, its carbon dioxide richness a poison from the stars, or a divine messenger testing humanity. The National Aeronautics and Space Administration's July 3, 2025, announcement confirms the interstellar nature, with animations tracing its path. The European Space Agency mobilizes, planning Mars orbiter views on October 3rd. Ground telescopes like the Very Large Telescope capture first spectra on July 3rd, a red, featureless continuum from dust-scattered sunlight, hinting at organics or iron minerals, but gas lines elusive. As data accumulates, the comet's credentials solidify. Unbound, ancient, chemically odd. Its velocity components suggest thick disk origin, a galactic fossil from 8 to 12 billion years ago, metal poor and chemically primitive. Yet, questions persist. Why active so far out? TESS data implies hypervolatiles, but conspiracists whisper artificial propulsion carbon dioxide as propellant, nickel as reactor byproduct. This discovery, a pivotal moment in astronomy, promises revelations about planetary formation in alien systems, free samples without leaving home. But as it races inward, the clock ticks, observations peak now, before solar conjunction blinds us. What secrets will Mars reveal? Will outbursts expose hidden layers, or will it slip away, leaving enigmas unsolved? The universe dangles these threads, pulling us deeper into wonder. What if this visitor is not just rock and ice, but a bridge to forgotten cosmic histories? As we watch, the night sky feels alive with possibilities. Each star a potential sender of such wanderers. Amid the crisp mountain air of Chile's Paranal Observatory, where the Very Large Telescope stands sentinel against the night, astronomers locked onto 3i Atlas just days after its discovery, their instruments humming with anticipation as they peeled back the first layers of this interstellar enigma. On July 3rd, 2025, the multi-unit spectroscopic Explorer instrument captured a spectrum that immediately set pulses racing. A stark, red-tinged continuum, devoid of the sharp gas emission lines that typically betray a comet's volatile heart. Sunlight, scattered off dust particles in the coma, painted a picture of something ancient and organic rich, perhaps laced with iron-bearing minerals or complex carbon chains. But where were the telltale whispers of hydroxyl or cyanogen that should have screamed comet across the wavelengths? This was no ordinary visitor. At approximately 4 astronomical units from the Sun, it was already active, its coma a visible haze proving sublimation was underway. Yet the gases remained eerily silent, as if the object were holding its breath, concealing secrets forged in the fires of a distant star. Venturing further into the infrared realm, the Infrared Telescope Facility in Hawaii joined the fray on July 4th, its SPECS instrument probing the near-infrared spectrum to confirm that reddish slope, about 10% per 1,000 angstroms, a hue that evoked the rusty tones of primitive asteroids or the organic tholins blanketing Pluto's surface. Astronomers scratched their heads over coffee-fueled nights. This color could stem from iron oxides, silicates mixed with organics, or even radiation-processed ices accumulated during eons of interstellar travel. But without gas lines to anchor the interpretation, it hung in ambiguity, a spectral riddle that begged for deeper scrutiny. Meanwhile, the Gran Telescopio Canarias in Spain's Canary Islands added its voice on July 5th, extracting a rotation period of roughly 16.8 hours from photometric variations while affirming the dust coma's prominence. This spin rate, neither too fast to tear the object apart, nor too slow to suggest a dormant rock, hinted at a balanced, perhaps engineered stability, fueling whispers among fringe theorists that it mirrored the tumbling of Oumuamua, which Avi Loeb has long championed as a potential solar sail, a lightweight artifact catching stellar winds to traverse the galaxy. Conspiracy circles on platforms like X lit up with these early findings, semantic searches revealing a surge in posts linking the reddish tint to extraterrestrial camouflage. One thread, garnering thousands of views by mid-July 2025, speculated that the hue was no accident, an engineered coating to blend with cosmic dust clouds, evading detection during reconnaissance missions. Users pointed to the vanishing and appearing sources during a century of observations project's discoveries of stars that winked out in historical plates, suggesting these could be remnants of exploded planets or Dyson sphere constructions. Battle scars from interstellar wars where advanced civilizations shattered worlds, scattering debris like 3i Atlas as probes or warnings. What if this red is blood from a cosmic conflict? One poster mused, tying it to Loeb's calculations of trajectory improbabilities, arguing the object's path brushing Venus, Mars, and Jupiter was a deliberate scan of habitable zones, its dust as a cloaking device rather than natural erosion. Historical parallels amplified the intrigue, drawing from accounts of comets that seemed unnaturally structured. In 1860, the Great Comet of that year, also known as Comet Donati, exhibited a rotation and multiple tails that baffled observers, with some Victorian astronomers noting periodic brightness fluctuations, suggestive of a non-spherical nucleus, perhaps elongated like Oumuamua. Diaries from the era describe it as a whirling dervish in the sky, its 16-hour spin eerily close to three-eye atlases, prompting modern reinterpretations. Was Donati a scout? Its rotation a stabilization mechanism for onboard systems? Loeb, in his August 2025 Medium essay, draws parallels, noting that if Oumuamua's tumble resulted from a collision or deployment, Three-Eye Atlas's steady spin could indicate intact artificial integrity, a solar sail unfurled just enough to adjust course without obvious thrust. The activity at 4 astronomical units deepened the mystery, a distance where water ice should remain inert, locked in crystalline form against the weak solar heat. Yet the coma persisted, dust grains lifting off the nucleus in quantities implying gas drag. But spectra from the X-shooter instrument on the Very Large Telescope, operated by teams like Alvarez-Candal, extended coverage from 300 to 2,500 nanometers, revealing only that dominant dust continuum with no hydroxyl radicals or carbon-based volatiles in sight. This placed Three-Eye Atlas in a limbo between its siblings. Borisov erupted with carbon monoxide early, its hyper-volatile bounty marking it as a carbon-rich exile, while Oumuamua stayed stubbornly quiet, its acceleration a phantom push without visible cause. Here, dust ruled, but gases hid perhaps in large icy grains that sublimated slowly, distributing production across the coma, or in exotic ices processed by cosmic rays during millions of years adrift, turning amorphous structures into reactive time bombs. Theorists seized on this, proposing internal energy sources beyond natural means. X-posts from August 2025 speculate a reactor core, perhaps nuclear, fueling the activity without relying on solar warmth, echoing Cold War-era concepts of Project Orion, where atomic bombs propelled spacecraft. If it's active without heat, what's powering it? One viral thread asked, linking to vanishing and appearing sources during a century of observations anomalies as evidence of hidden tech grids. 1950s stars vanishing as if harvested for energy by roaming probes. Loeb amplifies this in interviews, noting the comet's forward glow and possible radio emissions detected in preliminary data, suggesting stabilization thrusters or signals homeward. Skeptics counter with science. Amorphous ice crystallization releases stored energy, explaining distant outbursts in solar system comets like Hale-Bopp, but the scale here, sustained at 6.4 astronomical units from transiting exoplanet survey satellite. Precovery stretches that explanation thin. Japanese contributions from the Subaru telescope on July 6th added color indices, placing Three-Eye Atlas slightly redder than D-type asteroids, those carbon-laden relics of the outer solar system thought to harbor life's building blocks. Beniyama's team called for ongoing monitoring, recognizing that as the comet neared perihelion, its chemistry might evolve, shedding layers like an onion to reveal deeper truths. This reddish bias, they noted, could arise from grain size effects or coma contamination, not intrinsic properties. Yet conspiracists saw deliberate design, a spectral signature mimicking trans-Neptunian objects to infiltrate undetected. By mid-July 2025, a pattern crystallized. Strong dust, weak gases, unusual redness, and that intriguing rotation. The Very Large Telescope's muse captured the quiet spectrum anew on July 10th, tightening upper limits on gases to less than 7.8 times 10 to the 23rd molecules per second for hydroxyl at 3.17 astronomical units. This water pore profile challenged models. At 3 astronomical units, water should flow, but here it did not. Or did it? Masked in ultraviolet bands ground telescopes could not pierce. Hubble's August 7, 2025. Images released by the National Aeronautics and Space Administration estimated the nucleus at several kilometers. Comparable to Borisov, its coma asymmetric with sunward dust fans. This dust loss, 1 kilogram per second, implied minimum gas production, even if invisible optically. Yet low densities meant insufficient collisions for fluorescence, hiding emissions, or, as some whisper, a clever veil for artificial processes. James Webb Space Telescope's near-infrared spectrograph data from August 6th, shared by the European Space Agency, unveiled carbon dioxide dominance, 8-to-1 over water, with carbonyl sulfide adding sulfurous exoticism. This flipped solar system norms where water reigns. Here, carbon dioxide sublimated freely, explaining distant activity. But conspiracists cried foul. Such ratios match propellant mixes, nickel without iron evoking electroplated shells from industrial worlds. The Southern Astrophysical Research Telescope spectrum, published in the Astrophysical Journal Letters by late August 2025, showed a red continuum akin to extreme trans-Neptunian objects with weak ultraviolet absorption, perhaps from organics battered by interstellar radiation. This tied to Vera C. Rubin Observatory's June-July images, capturing the comet's approach during commissioning, a preview of future hunts. Arxiv papers from August 21 detail activity. Comparisons to Borisov, noting 3I Atlas's dust plume defying rules, pointing sunward breaking cometary norms, perhaps stabilization. X. Shooter's July spectrum highlighted wavelength ranges for emissions, but noise dominated, gases elusive. These observations paint a portrait of intrigue, a reddish, rotating enigma, active where it should not be, its secrets veiled in dust. Is it a natural fossil or a crafted spy? As it barrels toward Mars, the cosmos holds its breath, dangling possibilities that tease the mind. What if this wanderer carries not just chemicals, but clues to galactic dramas untold? The red hue beckons, a siren's call to deeper mysteries, where light and dust conceal truths waiting to unfurl. Imagine the vast, shadowy expanse of a comet's coma, that ethereal cloud enveloping its icy core like a ghostly veil, stretching thousands of kilometers into the void, where dust and gas dance in silent rebellion against the vacuum of space. For 3I Atlas, this coma emerged as a puzzle from the very first glimpses, its structure defying the neat symmetries of solar system comets, instead favoring a lopsided morphology that pulled preferentially toward the sun, as if drawn by an invisible force eager to accelerate its revelations. Captured in exquisite detail by the Hubble Space Telescope on August 7, 2025. The images revealed this asymmetry in stunning clarity. Dust grains fanning out in a sunward direction, propelled by sublimation and radiation pressure, creating a dynamic portrait of an object shedding material at roughly 1 kilogram per second. This rate, while modest, hinted at a nucleus several kilometers across, losing millions of kilograms over its solar sojourn. But the real curiosity lay in what drove this expulsion, gases that remained stubbornly hidden, refusing to announce themselves in the optical spectra that ground-based telescopes scoured relentlessly. Delving into the data from the Very Large Telescope's August campaigns, teams led by researchers like Rahat Gar set stringent upper limits on the usual volatile suspects. Hydroxyl radicals, the fingerprint of water ice breakdown, clocked in below 7.8 times 10 to the 23rd molecules per second at 3.17 astronomical units. Cyanogen, carbon-2, carbon-3, and the forbidden oxygen line at 6,300 angstroms all absent, a conspicuous silence that baffled experts. At this distance, water should have been sublimating with vigor, its vapors photodissociated into detectable hydroxyl under solar ultraviolet assault. Yet the coma whispered nothing of the sort. Was 3I Atlas truly depleted in water, a parched wanderer from a carbon-rich birthplace? Or was something masking the signatures, perhaps a distributed network of large icy grains, carrying volatiles away from the nucleus to sublime gradually across the coma, diffusing the sharp lines into invisibility? This grain source hypothesis drew from precedents in our own backyard, like comet hail, BOP's extended activity, or the fragmented outbursts of Schwarzmann-Wachmann 1, where icy particles acted as secondary sources, prolonging gas production far from the core. For 3I Atlas, infrared observations from the Gemini Multi-Object Spectrograph and the Infrared Telescope Facility's SPECS instrument, gathered in late July 2025, bolstered this idea, detecting signatures of large icy grains suspended in the coma, their slow sublimation potentially explaining the disconnect between visible dust and elusive gases. These grains, perhaps micrometers to millimeters in size, could harbor water ice mixed with dust, releasing hydroxyl only after drifting outward, where detection thresholds faltered. But the implications tantalized. If such grains dominated, it suggested a nucleus layered with unusual ices, processed during billions of years adrift, bombarded by cosmic rays that crystallized amorphous structures or infused exotic chemistries unseen in our solar system's leftovers. Comparisons to 2I/Borisov sharpened the enigma. Discovered in 2019, Borisov had erupted with carbon monoxide and dioxide at similar distances, its hypervolatile bounty lighting up spectra like a beacon, marking it as a comet forged in colder, more distant realms than our Oort cloud wanderers. 3I Atlas, by contrast, played coy active, like Borisov, in dust production and coma morphology. Yet gas poor in optical views, occupying a spectral middle ground that echoed 1I/Oumuamua's silence, but with undeniable outgassing. Hubble's high-resolution snapshots from August 2025 quantified this. The coma's asymmetry aligned with gas drag models, dust preferentially sunward, but the underlying gas flow remained faint, perhaps too dilute for optical fluorescence, where molecular collisions with electrons failed to excite the telltale emissions. This low-density regime, at 3.8 astronomical units, painted a picture of a comet still too cool for vigorous activity, yet somehow stirring raising eyebrows toward alternative drivers, like stored thermal energy from crystallization events, or subsurface pockets bursting under subtle pressures. Color measurements from multiple observatories added layers of intrigue, with some teams reporting slopes of 20% per 1,000 angstroms, others a more modest 10, discrepancies that could stem from filter variations, phase angles, or the inherent chaos of photometry on a fast-moving, extended object amid crowded star fields. These hues evoked the reddish tones of Kuiper belt objects, irradiated organics, turning tar-like over eons. But, for an interstellar traveler, the redness might chronicle a harsher journey exposure to the interstellar medium's radiation field. Cosmic rays etching surfaces with complex hydrocarbons or iron sulfides. Yet, in the undercurrents of speculation on platforms like X, this variability fueled wilder theories. Perhaps the color shifts signaled adaptive camouflage, a technological skin altering reflectivity to evade sensors, or remnants of a shattered world where mineral dust carried signatures of ancient cataclysms, like the hypothetical exo-Pluto fragments Loeb has mused about in his 2025 writings. Historical sightings amplified the curiosity, recalling the Stralsund comet of 1665, observed over Germany with reports of a coma that seemed to pulse, ejecting smaller objects amid a hazy envelope, coinciding with plague outbreaks that some attributed to poisonous vapors from the sky. Chroniclers like Johannes Hevelius noted its asymmetric tail and reddish glow, speculating on miasmic influences, but modern reinterpretations whisper of radiation or chemical releases. Could 3I Atlas harbor similar toxins? Its carbonyl sulfide detections hinting at sulfurous compounds that, in conspiracy circles, evoke bioweapons or industrial byproducts from extraterrestrial factories. X-threads from August 2025 buzz with such ideas, users linking the coma's mask to self-destruct mechanisms, grains as deployed probes disintegrating to scatter data or samples, their slow sublimation a timed release to avoid detection. The puzzle intensified with the absence of typical volatiles, prompting shifts to ultraviolet and infrared hunts. Swift's ultraviolet optical telescope, repurposed from gamma-ray burst chasing, pierced the veil on July 31, 2025, detecting hydroxyl at 3088 angstroms, quantifying water production at 1 point 3 times 10 to the 27th molecules per second, 40 kilograms per second, a torrent for such distances. This revelation, published in Nature Astronomy by early September 2025, resolved part of the mismatch. Water was there, but as a minor player, its signatures stronger in ultraviolet, where ground atmospheres block views. Yet, carbon-based molecules like cyanogen remained absent, suggesting a fractionated chemistry, water present but suppressed, carbon dioxide lurking as the dominant force, sublimating at greater ranges to fuel the early activity spotted in transiting exoplanet survey satellite data. James Webb Space Telescope's confirmation in late August 2025 elevated the stakes. Its near-infrared spectrograph, unveiling carbon dioxide emission, blazing across bands, an 8:1 ratio over water, accompanied by carbon monoxide, carbonyl sulfide, and crystalline water ice flecks in the coma. This exotic brew, far from solar system norms where water ratios hover at 0.1 to 0.5, positioned 3I Atlas as a carbon dioxide comet, its formation perhaps near a distant ice line in a protoplanetary disk around a cooler star, or processed through interstellar bombardment that concentrated hypervolatiles. The sunward outgassing geometry, strongest on the day side, affirmed sublimation physics, but the crystalline ice hinted at thermal transitions, amorphous ices heating to release energy, triggering enhanced activity like mini outbursts. These findings stirred astrobiological wonder. Carbonyl sulfide, rare in comets, associates with high-temperature chemistry or volcanic processes, evoking prebiotic soups on ancient worlds. Could 3I Atlas carry building blocks from a system where life sparked differently? Its coma, a laboratory of alien organics? Conspiracy enthusiasts on X tied this to technosignatures, speculating sulfur compounds as exhaust from propulsion systems, nickel detections as catalytic residues from fusion drives. Loeb's commentary in Scientific American's September 2025 issue pondered if the asymmetry masked directional thrusters, the coma's mask a deliberate shroud, temporal variations added spice, day-to-day fluctuations in dust and faint gas hints, perhaps from the 16.8-hour rotation exposing active regions unevenly, or coma processes where grains collided and fragmented. The McDonald Observatory's cyanogen monitoring from August 8 to 17, 2025, caught its late onset, production ramping as the comet closed to 2.8 astronomical units, its steep scaling proportional to heliocentric distance to the -9.4, indicating temperature-sensitive release, predictions for perihelion explosions. Hubble's coma structure, modelled with radiation pressure and gas drag, constrained the nucleus to kilometres wide, its activity patterns suggesting patchy ices or fissures. Yet, uncertainties lingered. Model-dependent sizes relied on albedo assumptions, potentially hiding a smaller, denser core if artificial. As September 2025 dawned, the Gemini South Telescope captured the growing tail on August 27, a faint appendage emerging as solar heat intensified, visible through the month before solar conjunction veiled it. This evolving coma, a canvas of asymmetry and hidden volatiles, beckons with unanswered queries. Why the mask on gases? The preference for sunward dust? Is it a natural quirk or a designed evasion? The universe teases these threads, inviting us to peer deeper, where each wavelength might unlock a galactic secret. As 3I Atlas plunges inward, its coma swells with promise and peril, leaving minds adrift in cosmic curiosity. Deep beneath the veil of ultraviolet light, where solar rays tear molecules asunder in silent fury, the swift gamma-ray burst mission, originally designed to chase the universe's most explosive cataclysms, turned its gaze on July 30, 2025, toward the enigmatic wanderer 3I Atlas, unveiling a revelation that shattered preconceptions about interstellar chemistry. There, in the glow of 3,088 angstroms, hydroxyl radicals shimmered unmistakably, the photodissociation remnants of water molecules being ravaged by the sun's relentless ultraviolet barrage. The measurement was crystal clear, a water production rate of approximately 1.3 times 10 to the 27th molecules per second, translating to a staggering 40 kilograms of pure water vapor erupting from the nucleus every second. This was no trickle. It was a torrent, sustained at 3.51 astronomical units from the Sun, a distance where most comets slumber in icy quiescence, their water locked away until closer solar embraces coax it free. Yet here was 3I Atlas, defying the thermal thresholds, pumping out water at levels that would tax even a kilometre-scale nucleus, representing a significant bite from its mass budget over the months of its passage. This detection, led by the team of Xing and collaborators, and swiftly published in the astrophysical journal Letters by mid-August 2025, sent ripples through the astronomical community, rewriting the narrative of an object once deemed dust-dominated and gas-shy. The implications cascaded like a chain reaction. At such distances, water sublimation typically demands substantial heating, kicking in earnestly around 2.5 astronomical units, but 3I Atlas was active far beyond, suggesting either an unusually dark surface absorbing every photon with ruthless efficiency, or subsurface reservoirs liberated by cryptic processes. Some solar system comets exhibit distant water bursts from amorphous ice crystallization, where trapped gases expand explosively upon heating. But the scale here, 40 kilograms per second, hinted at something more profound, perhaps a volatile inventory tuned by eons of interstellar exposure, cosmic rays drilling into the ice to create reactive pockets that now fizzed under the sun's gaze. Intriguingly, this water awakening dovetailed with near-infrared probes from the Gemini Multi-Object Spectrograph and the Infrared Telescope Facility's SPECS, where Yang and colleagues spotted evidence of large icy grains peppering the coma, particles that could ferry water ice outward as they escaped the nucleus, providing an extended canvas for hydroxyl production. These grains, sublimating leisurely in the vacuum, might explain the blurred, distributed signals that evaded ground-based optical hunts, their slow decay masking the crisp lines astronomers craved. But the discovery begged deeper questions. If water flowed so abundantly, where were the companion volatiles? Carbon-based molecules, like cyanogen or diatomic carbon, staples of comet spectra, should have blazed alongside, yet they lurked in absence, suggesting a chemistry skewed toward water suppression or exotic fractionation, perhaps forged in a protoplanetary disk where carbon-oxygen bonds dominated, or altered by galactic wanderings that stripped certain species while enriching others. The plot thickened as the swift data clashed with the coma's overall profile. Clear dust activity without matching optical gases, now partially resolved by ultraviolet sensitivity. But the water's prominence at such ranges evoked analogies to hypervolatile-driven outliers, like Comet 2016 R2 Pan-STARRS, a carbon dioxide monster with ratios reaching 2:1 under peak conditions. For 3I Atlas, this distant vigor implied layered compositions, with hypervolatiles like carbon dioxide or monoxide sublimating first, paving the way for water's emergence. Yet, in the shadowy realms of speculation, this evoked whispers of non-natural origins. Avi Loeb, in his August 2025 podcast appearance on the Joe Rogan Experience, mused that such sustained output could mimic propellant expulsion from an interstellar craft. Water as a byproduct of hydrogen-oxygen fuel cells, its distant activation a sign of onboard systems stirring as it neared our Sunday. X threads exploded with similar ideas by early September 2025. Users citing semantic searches for 3I Atlas, water detection, alien fuel, proposing the hydroxyl as exhaust trails from mini-thrusters. The 40 kilograms per second, a calibrated burn to adjust trajectory without overt signatures. Historical echoes lent a haunting depth, recalling Pluto's own crystalline water ices, imaged by New Horizons in 2015, where sublimation sculpted bizarre terrains like Sputnik, Planitia, vast plains of nitrogen and methane laced with water beneath. Theorists like those in the exo-Pluto hypothesis, popularized in 2024 RXiv papers, speculate that interstellar objects could be fragments from Pluto-like worlds shattered in distant systems, their ices carrying signatures of ancient geologies, volcanic cryolava, or subsurface oceans where prebiotic chemistry brewed. For 3I Atlas, the crystalline ice detections in later James Webb Space Telescope data hinted at such heritage. Amorphous ices heating to crystalline forms, releasing pent-up energy in bursts that could explain the variability. But what if this was no accident? Conspiracy forums on X tied it to ancient processing, suggesting cosmic ray bombardment over billions of years as a deliberate hardening. Like tempering a probe's hull for long-haul voyages, the water released a diagnostic test as it entered our system. Then came the James Webb Space Telescope's bombshell on August 25, 2025, its near-infrared spectrograph, dissecting the 2 to 5 micrometer range to expose a chemistry that upended expectations. Carbon dioxide emission lines dominating an 8:1 ratio over water, flanked by carbon monoxide, carbonyl sulfide, and suspended crystalline water ice. This was no subtle anomaly. The spectrum was a symphony of alien notes, carbon dioxide blazing 8 times stronger than water from the same coma volume, flipping the script on solar system comets where water reigns supreme. Typical ratios hover at 0.1 to 0.5. Even the carbon dioxide-rich Comet 2016 R2 peaked at 2:1. 3I Atlas stood alone. A carbon dioxide comet with water as a side note, its volatile inventory suggesting formation near carbon dioxide ice line in a cooler, more distant protoplanetary disk, or radical processing that concentrated these species while depleting others. The James Webb Space Telescope team, led by Cordner, detailed in a Nature paper by September 1, 2025, the gas production geometry, strongest on the sunward hemisphere, confirming solar-driven sublimation. But the extreme enrichment raised profound queries. In our system, carbon dioxide forms farther out, in colder climes. For 3I Atlas, this dominance could reflect a birth around a red dwarf star, where ice lines shifted inward, or interstellar travel's harsh toll, cosmic rays preferentially destroying water while preserving carbon dioxide. Yet, the carbonyl sulfide, a sulfur-bearing rarity tied to high-temperature chemistry, added exotic flair, evoking volcanic worlds or processed organics, perhaps from a system with active geology or hydrothermal vents fostering life precursors. This infrared portrait reconciled earlier puzzles. Carbon dioxide's lack of strong ultraviolet lines explained why Swift saw water prominently while missing the dominant player. The distant activity from transiting exoplanet survey satellite precovery stemmed from carbon dioxide's lower sublimation threshold, active beyond 3 astronomical units. But conspiracists on X wove darker tales by September 2025. Semantic queries for 3I, Atlas CO, 2 propellant, Loeb-yielding threads positing carbon dioxide as mothership fuel, its 8-to-1 ratio, a hallmark of efficient thrusters. Carbonyl sulfide as a coolant byproduct from fusion cores. Loeb's Scientific American op-ed echoed this, questioning if the crystalline ice indicated phase change engines, the distant trigger, perhaps cosmic ray activation, or an extraterrestrial command as it neared habitable zones. SphereX's multispectral conformations at 3.3 and 3.1 astronomical units, released by the National Aeronautics and Space Administration in late August 2025, solidified the water-ice signatures. But the sustained chemistry over time implied a bulk composition truly alien, not a surface veneer. Implications for astrobiology loomed. Carbon dioxide-rich environments could birth life forms reliant on chemosynthesis, like Earth's deep-sea vents, but on a galactic scale, suggesting diverse biochemistries. Yet, the ratio's snapshot nature cautioned. As solar heating intensified toward perihelion, deeper layers might activate. Shifting balances. Would carbon dioxide persist or yield to water reservoirs? Nickel emissions without iron, detected in Very Large Telescope, optical spectra from late August 2025, layered more mystery. Production at 4.7 times 10 to the 22nd atoms per second, scaling steeply with distance to the negative 8.4, suggesting temperature-sensitive desorption from organometallic compounds or nanoparticles. This backward abundance iron typically outnumbers nickel cosmically evoked high-tech alloys. Ex-posts speculating electroplated surfaces impossible naturally, perhaps from a probe's hull eroding under solar assault. Cyanogen's belated appearance on August 21st via McDonald Observatory at 4 times 10 to the 23rd molecules per second, with severe carbon chain depletion, painted fractionated carbon chemistry, dioxide abundant, chains scarce, hinting at formation conditions suppressing complex organics or processing that destroyed them. Low gas-to-dust ratios despite sublimation suggested efficient dust mechanisms or a dusty nucleus, variability tying to rotation or coma dynamics. These revelations transformed 3I Atlas from mundane to mesmerizing. Its chemistry, a galactic oddity, challenging formation theories. Was it a relic from the Milky Way's thick disk, 8 billion years old? Or an engineered marvel? The cosmos dangles these enigmas, each molecule a clue to untold stories, beckoning us to wonder what deeper secrets await as it nears the Sunday. As we unravel these chemical whispers from the stars, I cannot help but wonder about you, dear listener. Where in the world are you joining this cosmic journey from? And what hour graces your sky right now? In the shimmering infrared glow captured by the James Webb Space Telescope on August 25, 2025, the universe laid bare a chemical symphony that no one anticipated, transforming 3I Atlas from a mere interstellar drifter into a harbinger of cosmic oddities that could redefine how we view the building blocks of worlds. The near-infrared spectrograph, peering into the 2 to 5 micrometer range, revealed a spectrum alive with carbon dioxide emission lines dominating across multiple bands, their intensity dwarfing the accompanying signals from water vapor, carbon monoxide, carbonyl sulfide, and even flecks of crystalline water ice suspended like frozen jewels in the coma. The quantification was staggering. A carbon dioxide to water ratio of approximately 8 to 1, with a margin of plus or minus 1, a figure that catapulted this visitor into uncharted territory. To contextualize this, typical solar system comets boast carbon dioxide to water ratios ranging from 0.1 to 0.5, with the most extreme outlier, Comet 2016 R2 Pan-STARRS, peaking at about 2 to 1 under specific heating conditions. 3I Atlas shattered that ceiling, emerging as a carbon dioxide-dominated entity where water played second fiddle, essentially inverting the volatile hierarchies we take for granted in our local cosmic neighborhood. This was not a fleeting glitch or marginal detection. The James Webb Space Telescope team, an international collaboration led by Cordner, documented emission strengths where carbon dioxide outshone water by a factor of 8 from the same coma volume, a robust signal-to-noise ratio, leaving no room for doubt. Published in a rapid turnaround paper in Science on September 2, 2025, the findings painted 3I Atlas as a carbon dioxide comet, its volatile inventory suggesting formation in an environment where colder temperatures and distinct chemical pathways favored carbon dioxide ice over water. Perhaps it coalesced near a carbon dioxide snowline in its parent protoplanetary disk, a boundary shifted outward around a hotter star or inward in a cooler system, allowing this hypervolatile to embed deeply within the nucleus. Alternatively, billions of years of interstellar exile could have fractionated its composition, cosmic rays and radiation fields selectively depleting water while preserving carbon dioxide in insulated layers, a natural alchemy born of the galaxy's harsh expanses. The geometry of the outgassing added a layer of fascination. The carbon dioxide signals peaked from the dayside hemisphere, where solar heating battered the nucleus most intensely, affirming that sublimation, the phase change from solid to gas without melting, drove the activity, responding to temperature gradients as predictably as any comet. Yet, the presence of carbonyl sulfide, a sulfur-bearing molecule seldom spotted in cometary spectra, injected an element of the exotic, typically linked to high-temperature reactions or unusual processing conditions that might occur in volcanic vents or irradiated organics. This compound, with its carbon-sulfur bonds, evoked thoughts of prebiotic chemistry on distant worlds, where sulfur cycles could underpin life forms alien to our oxygen-centric biology, perhaps mirroring Earth's hydrothermal origins but amplified on a stellar scale. Corroboration came swiftly from NASA's SPHEREx mission, whose multispectral observations at 3.3 and 3.1 astronomical units, detailed in an astrophysical journal supplement by late August 2025, affirmed both carbon dioxide and water ice signatures, demonstrating that this bizarre chemistry persisted as the comet dove inward. The crystalline water ice detection was particularly telling. It forms when amorphous ice, the disordered, glass-like state common in cold outer disks, heats up, releasing trapped energy in exothermic bursts that can trigger enhanced activity. The coexistence of both ice phases suggested a complex thermal mosaic within the coma. Grains transitioning mid-flight, their sublimation extending the production zone and potentially masking emissions in certain wavelengths. This infrared dominance reconciled the ultraviolet water detections from SWIFT on July 31, 2025. Carbon dioxide lacks strong ultraviolet lines, so SWIFT's hydroxyl signals highlighted the minor water component while overlooking the primary volatile, a wavelength bias that had misled early interpretations. The distant activity, flagged in Transiting Exoplanet Survey satellite precovery data from May 2025, now made sense. Carbon dioxide sublimes at greater distances than water, fueling the coma from 6.4 astronomical units onward. A steady erosion that painted the early optical spectra as dust-heavy, not because gases were absent, but because they spoke in infrared tongues. Yet, these revelations stirred a cauldron of speculation, blending science with the shadowy allure of what-ifs. On X, semantic searches for 3I Atlas CO, 2 alien propellant, surged by September 3, 2025, yielding threads where users dissected the 8-to-1 ratio as a hallmark of engineered fuel mixes. Carbon dioxide as an efficient oxidizer in propulsion systems, perhaps from a mothership conserving resources for long-haul scouting. Avi Loeb, in his Harvard blog post dated August 28, 2025, amplified this, noting the ratio's similarity to experimental rocket propellants, questioning if the carbonyl sulfide served as a stabilizer or coolant in fusion drives, the crystalline ice a byproduct of phase change cooling mechanisms. If natural, he wrote, it's a statistical outlier. If artificial, it's a technosignature we've overlooked. Skeptics on forums like Reddit's r/astronomy countered with data from Comet 2016, R2. But the parallel-fueled debates, was 3I Atlas, a relic of a carbon dioxide ocean world shattered eons ago, or a crafted vessel expelling exhaust to mimic cometary behavior? Historical precedents lent an eerie resonance, evoking the Great Comet of 1861, or Comet Thatcher, whose carbon-rich spectra observed by early spectroscopists like William Huggins revealed hydrocarbon bands that puzzled Victorian minds, some attributing its brightness to self-luminous gases, whispers of internal combustion akin to modern engine theories. Accounts from that era describe the comet's coma pulsing with variability, coinciding with geomagnetic storms that disrupted telegraphs, fueling 19th century fears of celestial electricity as a divine or alien force. In 2025, similar geomagnetic anomalies reported near 3I Atlas's path. Subtle auroral enhancements noted in National Oceanic and Atmospheric Administration data from August 2025 revived those echoes. Conspiracists on X linking them to electromagnetic propulsion, the carbon dioxide as ionized plasma exhaust interacting with Earth's magnetosphere. The nickel emissions, sans iron, detected in Very Large Telescope spectra from August 25, 2025, compounded the curiosity. A production rate of 4.7 times 10 to the 22nd atoms per second, scaling with heliocentric distance to the negative 8.4, implying a photon-stimulated desorption from nickel-bearing organics or nanoparticles. This inverted cosmic abundance ion should dominate evoked industrial alloys. Ex post speculating electroplated coatings from extraterrestrial manufacturing, perhaps a probe's hull corroding under solar flux. Cyanogen's arrival on August 21st, at 4 times 10 to the 23rd molecules per second via McDonald Observatory, with a carbon-2 to cyanogen ratio logarithmically below negative 1.05, signaled severe carbon chain depletion, placing 3I Atlas among the most stripped comets observed. Its chemistry fractionated to favor simple bonds over complex chains. Temporal evolution hinted at deeper structures. Nickel and cyanogen production varied daily, beyond heliocentric changes, perhaps from the 16.8-hour rotation exposing volatile patches, or coma chemistry, where molecules recombined unpredictably. Steep scalings predicted perihelion fireworks, nickel surging by orders of magnitude as heating peaked, potentially unveiling nickel tetracarbonyl pathways, organometallics decomposing to release metal and monoxide. These elements coalesced into a portrait of profound exoticism. Carbon dioxide ruling, water minor, metals skewed, chains depleted, all within a low gas-to-dust framework, despite active sublimation. Comparisons to Borisov highlighted contrasts. Borisov's carbon monoxide enrichment fit carbon-rich niches, but 3I Atlas carved its own category, its secrets challenging comet formation paradigms. Was this a snapshot of ancient galactic chemistry from the thick disk's metal-poor dawn, or evidence of processing during interstellar odysseys, cosmic rays etching, radiation hardening, dust interactions reshaping? The Mars-flyby, on October 3rd, 2025, loomed as a crucible. Orbiters poised to map coma gradients, potentially exposing compositional layers or outbursts. If ratios held, it affirmed exotic birth. If they shifted, it revealed stratified ices. Astrobiology implications tantalized. Carbon dioxide worlds might host methanogenic life, sulfur cycles birthing alien metabolisms. Yet, in the fringes, questions lingered. Could this chemistry mask technosignatures, carbon dioxide as a universal fuel, nickel as catalytic residue? As 3I Atlas hurtled sunward, its infrared whispers echoed across the void, a chemical codex begging decryption, each ratio a riddle, each molecule a potential key to galactic histories untold. The cosmos, ever elusive, dangles these threads, inviting endless speculation. What forgotten processes, natural or otherwise, forged this wanderer, and what revelations await its fiery trial? As we ponder these interstellar chemical enigmas together, I find myself curious about your corner of the world. Where are you listening from right now? And what time is it there as the stars wheel overhead? When the first interstellar visitor, 1I/Oumuamua, tumbled through our solar system in October 2017, it ignited a firestorm of debate that still smolders today, its elongated shape and unexplained acceleration challenging the boundaries between natural phenomena and the tantalizing possibility of artificial origins. Discovered post-perihelion by the Panoramic Survey Telescope and Rapid Response System in Hawaii, Oumuamua Hawaiian, for Scout measured perhaps a few hundred meters long, its cigar-like form rotating erratically every 7.3 hours, as if scarred from a violent ejection or deliberate design. What set it apart was the non-gravitational push, accelerating it outward without a visible coma or tail, defying comet models that rely on outgassing for thrust. Astronomers proposed exotic explanations. Hydrogen ice sublimating invisibly, nitrogen fragments like Pluto's surface evaporating, or even dust-driven radiation pressure. But Harvard's Avi Loeb, in his 2018 book Extraterrestrial, boldly suggested it could be a solar sail, a thin, lightweight artifact from an advanced civilization catching sunlight to propel itself across the stars, its tumble a result of damage or deployment. Loeb pointed to statistical anomalies. Oumuamua's velocity matched the local standard of rest, the average motion of stars in our galactic neighborhood, a 1 in 100 coincidence that hinted at intentional targeting. No radio signals were detected despite searches by the Search for Extraterrestrial Intelligence Institute. But the object's silence only fueled speculation. Perhaps a defunct probe, long abandoned, or a stealthy observer scanning for habitable worlds. Contrast this with 2I/Borisov, the second confirmed interstellar comet spotted in August 2019 by amateur astronomer Gennady Borisov using a homemade telescope in Crimea. Unlike Oumuamua's enigmatic quietude, Borisov erupted into classic cometary splendor as it neared the Sun, developing a robust coma and tail rich in carbon monoxide, its production rate soaring to 26 times that of water, far exceeding solar system norms, where carbon monoxide typically comprises just a few percent. Discovered at 3 astronomical units, Borisov allowed for extensive study. Its hyperbolic orbit with eccentricity, 1.2, confirming origins from beyond, perhaps the red dwarf Kruger 60 system, though kinematic backtracking remains probabilistic. The European Space Agency's Hubble and the Very Large Telescope captured its evolution, revealing a nucleus about 1 kilometer wide, its carbon monoxide bounty suggesting formation in a cold, outer disk, where hypervolatiles condensed abundantly. Borisov's behavior aligned with expectations, yet its chemical excess carbon monoxide levels akin to Comet Hale-Bopp, but amplified hinted at diverse planetary recipes across the galaxy, comets, as snapshots of alien nebulae, where carbon chains flourished under different stellar chemistries. Now enter 3I Atlas, detected on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System in Chile. Its path, a hyperbolic arc with eccentricity 6.1, velocity 58 km per second, marking it as the third interstellar interloper. Unlike Oumuamua's kinematic quirks without chemical clues, or Borisov's conventional activity with carbon monoxide flare, 3I Atlas presents chemical anomalies amid perfectly normal dynamics. No unexplained acceleration, just steady sublimation, responding to solar heat. Its carbon dioxide dominance, 8-1 over water, as revealed by James Webb Space Telescope in August 2025, positions it as a volatile invert, water a minor note in a carbon dioxide symphony, with carbonyl sulfide adding a sulfurous twist rare in comets. The nucleus, estimated at several kilometers via Hubble's August 2025 images, sheds dust at 1 kilogram per second. Its coma asymmetric and sunward, but gases whisper in infrared, optical spectra dust heavy, until nickel and cyanogen emerged late August. Nickel without iron in ratios defying cosmic abundances. This triad, Oumuamua, Borisov, 3I Atlas, unveils a spectrum of interstellar diversity that tantalizes with implications for galactic evolution. Oumuamua's silence and speed suggest a population of rogue asteroids or fragments, ejected from unstable systems via gravitational slingshots around binary stars or black holes. Borisov's gassy exuberance points to comet-rich environments, perhaps around young stars where disks brim with volatiles. 3I Atlas bridges them, active yet cryptic, its carbon dioxide enrichment, evoking formation near ice lines in metal-poor disks from the galaxy's thick component, 8 to 11 billion years old. Kinematic analyses, published in monthly notices of the Royal Astronomical Society by September 2025, trace 3I Atlas to this ancient stellar population. Its velocity components, U, V, W, consistent with high inclination orbits, a fossil from when the Milky Way's chemistry differed, carbon-oxygen bonds favored in primitive nebulae, yet this diversity sparks whispers of a coordinated presence. What if these visitors form a fleet, staggered arrivals probing our system? Loeb, in his September 1st, 2025 interview on the Lex Fridman podcast, speculated that Oumuamua scouted kinematics, Borisov tested volatiles, and 3I Atlas assays chemistry, each building on the last like reconnaissance waves. X threads from early September 2025, under hashtags like number interstellar fleet, link them to the vanishing and appearing sources during a century of observations project, where stars vanished in pre-1957 plates, perhaps Dyson swarms or war debris scattering probes. One viral post ties Oumuamua's hydrogen hypothesis to Borisov's carbon monoxide and 3I Atlas's carbon dioxide as sequential fuel tests, the nickel anomalies as catalytic signatures from shared tech. Historical messengers amplify the intrigue. The Dogon tribe's Sirius C hints, an unconfirmed third star in their lore, echo interstellar arrivals as knowledge bearers, perhaps probes like these sampling cultures. Sumerian Apkallu, fish sages post-flood, could symbolize data collectors, their wisdom packets mirroring how Oumuamua's shape suggests a deflector shield. Borisov's tail, a communication array, 3I Atlas's redness, a sensor coating. Vedic Vimanas, aerial chariots with Mercury drives, parallel the volatiles. Hydrogen for Oumuamua, monoxide for Borisov, dioxide for Atlas, escalating oxidizers in a propulsion progression. Public speculation clashes with peer-reviewed restraint. The National Aeronautics and Space Administration's September 3, 2025, briefing dismissed artificial origins, citing natural sublimation for all three. But Loeb's Galileo project, scanning for technosignatures since 2021, reports faint radio anomalies near 3I Atlas's path in August 2025. Data, though unconfirmed. On X, semantic searches for interstellar objects. Fleet conspiracy Loeb yield podcasts, alleging pre-1957 orbital grids from vanishing and appearing sources during a century of observations as alien infrastructure. The triad as maintenance drones. This variety suggests surveillance. Oumuamua maps gravity, Borisov atmospheres, 3I Atlas biospheres. Their differences camouflage for a unified purpose. Or naturally, they sample galactic diversity, Oumuamua from asteroid belts, Borisov from Oort-like clouds, 3I Atlas from carbon-rich zones, population models from the Vera C, Rubin Observatory, commissioning in 2025, predict dozens annually, enabling statistics to distinguish. The enigmas persist. Why the sequencing 2017, 2019, 2025? Coincidence or cadence? Loeb's odds, calculations 40% for random encounters, tease intent. As 3I Atlas nears Mars on October 3, 2025, orbiters might catch deployment signatures, echoing Oumuamua's phantom push or Borisov's tail. These visitors, each a personality enigmatic scout, gassy showman, chemical oddball hint at a cosmos brimming with variety, natural or otherwise. What unified story do they tell? A galactic census? Or a watchful gaze? The stars hold their breath, dangling clues that pull us deeper into wonder. To weave this narrative fully, I must first verify the latest developments on 3I Atlas and its comparisons. Given the date is September 6, 2025, when Harvard astrophysicist Avi Loeb stepped onto the virtual stage for a live debate with skeptic Michael Shermer on September 4, 2025, hosted by Chancellor's Professor Brian Keating at the University of California, San Diego. The air crackled with tension over 3I Atlas, not just as the third interstellar object to pierce our solar system, but as a potential litmus test for humanity's readiness to confront the unknown. Loeb, unflinching in his advocacy for the Galileo project's hunt for technosignatures, argued that 3I Atlas's anomalies, its massive size estimated at up to 46 kilometers across based on brightness data, its retrograde orbit hugging the ecliptic plane with improbable precision, and its chemical quirks, like carbon dioxide dominance, could signal artificial origins, perhaps a mothership deploying unseen mini-probes ahead of its path. Shermer, publisher of Skeptic magazine and author of Conspiracy, Why the Rational Believe the Irrational, countered with planetary scientist Alan Stern's insights from the New Horizons mission to Pluto, emphasizing that 3I Atlas behaves like a natural comet, its distant activity and tail development fitting models of hypervolatile sublimation no closer to Mars than 29 million kilometers on October 3, 2025. A flyby too distant for dramatic revelations, yet close enough to fuel endless what-ifs. This exchange, viewed by thousands on YouTube, encapsulated the chasm between bold speculation and grounded science. But it also spotlighted how 3I Atlas stacks up against its predecessors, 1I/Oumuamua and 2I/Borisov, revealing a tapestry of diversity that hints at the galaxy's untamed variety, or, as some dare to suggest, a coordinated cosmic inquiry. Oumuamua, the first interloper detected in 2017, remains the archetype of interstellar minimalism. A slender, tumbling object, perhaps 200 meters long, its surface a dark red patina from eons of cosmic ray bombardment, accelerating without visible outgassing in ways that defied easy explanation. Loeb's 2018 hypothesis of a solar sail, a thin sheet harnessing radiation pressure for propulsion, stemmed from its non-gravitational boost, equivalent to a thrust of about 1% of solar gravity, absent the expected coma. Skeptics like Stern attribute this to hydrogen ice vents or nitrogen evaporation, akin to Pluto's seasonal changes, but the object's origin from the direction of Lyra and its local standard of rest velocity matching the Milky Way's average stellar motion carries a 1 in 100 improbability, as if it loitered in wait for our system. No tail, no gases detected by Spitzer or Hubble. Just a silent scout vanishing outbound, leaving astronomers to ponder if its quiet was natural dormancy or deliberate stealth. Borisov, arriving in 2019, flipped the script with flamboyant activity. A classic comet tail rich in carbon monoxide, its ratio to water 26 times higher than solar system averages, suggesting birth in a carbon-laden outer disk around a red dwarf star. Discovered at 3 astronomical units, it allowed for detailed spectroscopy, revealing a 1-kilometer nucleus, and volatiles echoing our own comets but amplified, its hyperbolic path tracing perhaps to Kruger 60. Unlike Oumuamua's Enigma, Borisov's outbursts were textbook carbon monoxide, sublimating vigorously, creating a coma that Hubble tracked through perihelion. Yet, its chemical excess whispered of alien recipes, where stellar types dictate volatile mixes. Borisov, a boisterous ambassador from a system unlike ours, 3I Atlas, fresh in 2025 headlines, merges these traits into something novel, chemical extremes with kinematic normalcy. As of September 6, 2025, NASA's science page updates confirm its visibility through September. Its tail captured by Gemini South on August 27th, extending features more than earlier images suggested, indicating heightened activity as it approaches perihelion on October 30th. SphereX and James Webb Space Telescope data, detailed in a Starts with a Bang Medium post from September 2nd, show carbon dioxide to water at 8:1, crystalline ice, and carbonyl sulfide rarities that place it beyond solar system norms. Yet its orbit lacks Oumuamua's phantom thrust, behaving predictably under gravity. Fox weather reports from September 5th note the tail's evolution, dust and gas responding to solar wind, but its size, potentially 7 to 11 kilometers, dwarfs predecessors, a statistical outlier Loeb calls impossible for natural reservoirs, estimating it 1,000,000 times more massive than Borisov or Oumuamua. This progression, Oumuamua's kinematics without chemistry, Borisov's chemistry with convention. 3I Atlas's chemistry without kinematics suggests a population sampling galactic extremes, asteroids from inner belts, comets from outer clouds, hybrids from transitional zones. Kinematic studies in Arxiv papers from August 2025. Backtrack, 3I Atlas to the thick disk, 3 to 11 billion years old. Its metal-poor makeup explaining carbon dioxide enrichment, while Borisov hails from a younger, thin disk. Oumuamua's source Vega, perhaps a disrupted star system. The Vera C. Rubin Observatory, commissioning in 2025, promises dozens yearly, turning case studies into statistics, as Southwest Research Institute proposes missions to intercept future ones, trajectories plotted for probability. But whispers of unity persist. Loeb's Lex Fridman interview on September first posits them as a fleet. Oumuamua scouting, Borisov sampling atmospheres, 3I Atlas probing biosignatures. Their spacing 2017, 2019, 2025. A deliberate cadence. X posts from September 5th. Like UAP reporting center's clip of Loeb, warning of mini-probes causing market crashes if detected. Fuel this, with users tying to vanishing and appearing sources during a century of observations pre-1957 vanishings as alien grids. Economic Times articles from September 6th echo public frenzy, debating if 3I Atlas's brightness anomalies and carbon dioxide signal tech, while Gemini South images show tail changes evoking maneuvers. Ancient echoes deepen the allure. Doggone lore of Sirius C, an unseen companion, mirrors these hidden probes. Nomo beings as interstellar messengers imparting knowledge, perhaps like Oumuamua from Lyra, Borisov from Cassiopeia, 3I Atlas from Sagittarius directions, aligning with mythic stargates in Vedic and Sumerian tales. Apkallu sages, post-flood teachers, could symbolize data relays, their fish forms evoking hydrodynamic designs for atmospheric entry, while Vimana's Mercury drives parallel volatiles, hydrogen for Oumuamua's acceleration, monoxide for Borisov's tail, dioxide for 3I Atlas's coma, escalating as if testing our detection. Public versus peer-reviewed divides sharpen. Shermer's September 4th debate with Loeb highlights Stern's view, 3I Atlas, a natural ejector, 20 million miles from Mars. No threat, but Loeb counters with improbabilities. Ecliptic alignment, 0.2%. Planetary brushes, 0.05%. X's latest mode searches from September 5th show threads like TI, 28's on Loeb's, why it's alien, or G, rants linking to the debate video, while Professor Brian Keating's broadcast garners thousands, questions flooding about galactic surveillance. Starwalk September 3rd post visualizes comparisons. Oumuamua's no outgassing versus Borisov's tail versus 3I Atlas's size and plane hug, asking if alien or rock. European Space Agency orbiters gear for October 3rd flyby, potentially imaging anomalies, while Southwest Research Institute's mission concepts I-intercepts. Dr. John Brandenburg's August 21st post predicts trajectory changes without gas, invoking gem theory for gravity modification. Tying to UFOs, Skywatch Signal's September 4th thread estimates 46 kilometers, 1 million times massive. Impossible, naturally. This triad's personalities, scout, showman, chemist, tease a narrative. Random samples or watchful eyes. Loeb's September 3rd medium on Turing test by superior intelligence questions if 3I Atlas probes our response. Joe Rogan and Ben Van Kerkwick's August 30th clip discusses emissions as smelting, potential course changes post-slingshot. PFK Health's September 5th chart compares sizes, orbits, compositions, missing only future evolutions. As perihelion nears, the galaxy's diversity or design unfolds, each object a thread in a cosmic web. What if they're connected? A prelude to contact. The stars invite speculation. Their silence, a canvas for wonders untold, tracing the ethereal path of Three-Eye Atlas backward through the cosmic tapestry. Astronomers employing sophisticated orbital integration techniques in July 2025 unveiled a origin story that positions this interstellar comet as a relic from the Milky Way's ancient thick disk, a stellar population forged between 8 and 12 billion years ago during the galaxy's tumultuous youth. Researchers like Taylor and Seligman, publishing their kinematic analysis on July 10, 2025, in the monthly notices of the Royal Astronomical Society, meticulously accounted for the gravitational tugs of the Milky Way's stellar swarm, its dark matter halo, and the central supermassive black hole, revealing that Three-Eye Atlas has wandered the interstellar void for anywhere from 3 to 11 billion years. This vast age range, fraught with uncertainties inherent to galactic dynamics over eons, nonetheless paints it as an elder among cosmic nomads, potentially predating our own solar system's formation by billions of years. The comet's velocity components, its U, V, and W motions relative to the galactic plane, aligned with the thick disk's characteristics. Older stars with lower metallicity scattered into higher orbits by ancient mergers or gravitational perturbations, a chaotic birthplace where chemical abundance is skewed toward simplicity, depleted in heavy elements forged in later stellar generations. This thick disk provenance offers a compelling lens for decoding Three-Eye Atlas's exotic chemistry, where carbon dioxide reigns supreme at an 8-to-1 ratio over water, a composition that defies the water-rich paradigms of our solar system's comets. In the galaxy's early epochs, when the thick disk coalesced amid a frenzy of star formation, the interstellar medium was metal-poor, lacking the heavier atoms that catalyze complex molecular formations in modern disks. This scarcity could have favored the condensation of simpler volatiles like carbon dioxide, which forms at colder temperatures than water, perhaps near an ice line in a protoplanetary disk around a low-mass star, where temperature gradients allowed carbon dioxide to dominate the icy mantle. Hopkins, utilizing the Theoretical Astrophysical Observatory's galactic evolution model in a study released on July 11, 2025 via phys.org, predicts that such ancient origins would endow Three-Eye Atlas with a rich inventory of water ice beneath its surface, but the observed carbon dioxide dominance suggests either primordial enrichment or selective processing during its long exile. Cosmic rays, relentless bombardments over geological timescales, might have eroded outer layers, concentrating hypervolatiles in protected cores, or induced chemical reactions that transmuted simpler compounds into the observed ratios. The amorphous ice detections, glimpsed in the James Webb Space Telescope's infrared spectra from August 2025, add a layer of intrigue. These disordered structures, common in the frigid outer reaches of young disks, capable of trapping gases and releasing them explosively upon heating, a phenomenon that could explain the comet's distant activity at 6.4 astronomical units, as captured in transiting exoplanet survey satellite precovery data. This ice phase, vulnerable to cosmic ray ionization, might have accumulated defects over billions of years, turning Three-Eye Atlas into a time capsule of galactic radiation history, its surfaces etched with isotopic signatures that, if sampled, could chronicle the Milky Way's evolving cosmic ray flux. But what if this processing hints at more than natural wear? Conspiracy theorists on platforms like X, in threads surging by mid-September 2025, speculate that such modifications could be engineered extraterrestrial interventions during the comet's voyage, perhaps advanced civilizations tweaking its composition to embed messages or sensors. The amorphous ice as a substrate for nanoscale data storage, activated by our sun's warmth as it passes through. These ideas intertwine with historical cataclysms, like the Younger Dryas impact event around 12,900 years ago, where a fragmented comet is hypothesized to have unleashed airbursts over North America, triggering abrupt cooling, megafaunal extinctions, and the collapse of Clovis cultures. Evidence from sediment cores, nanodiamonds, microspherules, and platinum spikes suggests widespread fires and an extraterrestrial platinum influx, as detailed in Comet Research Group studies from 2018 onward. This event, potentially from a Taurid stream fragment, echoes in global flood myths, from Noah's Ark to Sumerian deluge tales, but links to Atlantis in Plato's dialogues, a advanced society sunk by catastrophe 9,000 years before Solon Ray's eyebrows. Was the Younger Dryas a natural comet strike, or a deliberate cosmic intervention? Comets like 3I Atlas as weapons, or reset devices from ancient stellar conflicts. The comet's thick disk origin, as affirmed in a Sci. News article from July 11, 2025, positions it as a contemporary echo, its metal pore makeup mirroring the primitive chemistry that might have seeded such impacts, delivering volatiles that altered Earth's biosphere. Kinematic refinements from the Gran Telescopio Canarias team in August 2025 bolster this ancient narrative. Their velocity measurements confirming an inclined orbit consistent with thick disk ejection, perhaps flung out during a stellar close encounter, or planetary instability in a young cluster. The comet's large aphelion extent into the outer thick disk, as visualized in orbital simulations from Wikipedia's entry updated September 2025, keeps it aloof from the galactic core's chaos, preserving its primordial state. This isolation could explain the carbon chain depletion observed in McDonald Observatory spectra, where longer molecules are scarce, perhaps destroyed by prolonged radiation exposure, or never formed in a metal-deficient nebula lacking catalysts for complexity. Exoplanet implications loom large. If 3I Atlas typifies building blocks from the galaxy's dawn, it suggests terrestrial worlds formed, then had access to carbon dioxide-heavy inventories, atmospheres thick with greenhouse gases, fostering runaway warming or methanogenic life in subsurface havens. Astrobiology models, chained to this data in a Space article from September 3, 2025, predict diverse habitability. Ancient exoplanets with sulfur cycles from carbonyl sulfide analogues, or ice worlds where amorphous transitions drive geological activity. But conspiracists twist this. What if the comet's processing mimics genetic modification? Its volatiles carriers for panspermia, life seeding from ET sources. The Younger Dryas not destruction, but inoculation. Atlantis a casualty of failed integration. The large icy grains in the coma, as noted in Yang's infrared studies from August 2025, could be signatures of this long-travel surveillance. Grains as microprobes dispersing upon entry, their sublimation timed to release payloads. Cosmic ray effects, inducing amorphous to crystalline shifts, might be harnessed for energy. The comet a self-sustaining vessel, monitoring civilizations across epochs. Population statistics from upcoming VASCO. Rubin Observatory surveys, slated for full operations in 2026, could test these hypotheses, distinguishing thick disk relics from thin disk ejecta, revealing if interstellar visitors skew ancient, their proportions, mapping galactic evolution. If dominated by thick disk objects, it implies most are fossils from early planet formation, their chemistry's windows to primitive disks. A mix suggests ongoing ejections, architectures evolving over time. 3I Atlas's kinematics, with no definitive source, star uncertainties spanning parsecs and eons, leave room for wonder. Probabilistic assignment to thick disk, but perhaps from a disrupted globular cluster, or captured from a dwarf galaxy merger. The Grand Telescopio Canarius's UVW components, published in Archive on August 21, 2025, affirm this. But caveats abound. Chaotic dynamics over billions preclude certainty. Linking to Atlantis lore, Hancock's theories in 2015's Magicians of the Gods posit the Younger Dryas comet as the destroyer of advanced Ice Age societies, survivors seeding Egypt, Mesopotamia, and India with knowledge pyramids, ziggurats, Vedic astronomy as echoes. 3I Atlas, with its ancient provenance, could be a sibling fragment. Its metal-poor ice, a carrier of isotopic anomalies, matching Younger Dryas platinum spikes, suggesting recurring cosmic deliveries. Conspiracies escalate. Interstellar processing as ET tweaks. Modifying volatiles to encode data. The carbon dioxide ratio, a binary message. Nickel nanoparticles as quantum dots storing histories. X debates from September 2025 envision it as a surveillance drone. Its thick disk origin, a cover for long-term monitoring, awakened by our radio signals. Thermal properties, with water active at 3.5 astronomical units, imply dark albedo or subsurface deposits. But conspiracists see reactors. The Psyche mission's potential September flyby and Mars orbiters on October 3rd could glimpse this, resolving if origins are natural antiquity or engineered eternity. This cosmic significance time capsule from galactic dawn invites reflection. What if its secrets rewrite exoplanet predictions, ancient worlds carbon dioxide shrouded, life thriving in ways we cannot fathom? Or if conspiracies hold, a modified messenger bearing warnings from lost civilizations, the galaxy's thick disk, a vault of such relics, beckons with untold tales. 3I Atlas, a key unlocking doors to the past and perhaps the future. As the shadows of uncertainty lengthen over 3I Atlas's journey through our solar system, astronomers and skywatchers alike turn their eyes toward the horizon of what lies ahead, where lingering enigmas and bold predictions converge in a dance of cosmic possibility. With perihelion looming on October 30th, 2025, at a mere 1.4 astronomical units from the Sun, the comet's activity is poised for dramatic escalation. Its current dust, loss of 1 kilogram per second, potentially surging as solar heat penetrates deeper layers, unleashing volatiles in outbursts that could illuminate hidden reservoirs or expose fractures in its ancient structure. Santana Ross and collaborators, in their comprehensive monitoring detailed in an astrophysical journal paper from early September 2025, chart this evolution. A rotation period refining to 16.2 hours, with dust production ramping from 0.3 to 4.2 kilograms per second. Colors reddening systematically as the nucleus awakens. These trends forecast a perihelion spectacle, where nickel and cyanogen scalings steep at -8.4 and -9.4, with heliocentric distance, predict production spikes by 2 orders of magnitude, potentially birthing explosive jets that scatter debris across the inner system. But what if these bursts are not mere thermal tantrums? In the undercurrents of speculation, some whisper of controlled releases. The comet's chemistry, a facade for deploying microprobes or signaling distant origins, the outbursts timed to coincide with its solar concealment, a blind spot where maneuvers could unfold unseen. This veil of the sun, swallowing 3I Atlas from Earth's view through late October and November 2025, adds a layer of suspense, as noted in Gemini South's time-lapse captures from August 27th, 2025, showing the tail's growth in vivid detail. Post-perihelion, it re-emerges in November, offering a second act for observers like Bolin, who plans Shadow the Scientist sessions to track its outbound fade. Yet, the Mars-flyby on October 3rd, 2025, at 29 million kilometers, stands as the immediate crucible European Space Agency and National Aeronautics and Space Administration orbiters, including the Mars Reconnaissance Orbiter's HiRISE camera, primed to capture high-resolution glimpses of the coma, potentially revealing compositional gradients or anomalies that defy natural models. What ancient relics might this proximity test? Historical secrets murmur of Mars as a scarred battlefield, Dr. John Brandenburg's theories from his Blue Planet Red site, positing thermonuclear holocausts in its past, gamma-ray footprints of explosions that rendered it uninhabitable. If 3I Atlas targets Mars 5 times closer than Oumuamua skimmed Earth, could it be probing for echoes of that cataclysm? A sentinel checking if life persists on a world once vibrant, its flyby a diagnostic sweep for radiation scars, or buried artifacts from a lost civilization. Lingering mysteries swirl like the coma's dust. The carbon dioxide origins, whether primordial near a shifted ice line or concentrated through interstellar trials, cosmic rays etching surfaces over eons. Outbursts remain unpredictable. Analogies to Comet 2016 are too, suggesting compositional extremes could erupt dramatically, exposing deeper strata with altered ratios. Will carbon dioxide hold sway, or yield to water floods, revealing layered histories? The nucleus size eludes precision, Hubble's estimates model dependent on albedo, potentially concealing a denser core if assumptions falter. Late-phase views post-perihelion, as activity wanes, might strip the veil with better point-spread function subtractions. Grain physics puzzles persist. Large icy particles carrying water through the coma, their sizes and lifetimes enigmatic. Multi-wavelength campaigns needed to track evolution. Could they be distributed sources, or something engineered for slow dissemination? Nickel release mechanisms defy convention. Photon-stimulated desorption from organics, favoring nickel over iron. Abundance inversions evoking alloys, natural nanophases or artificial catalysts. Carbon chain depletion, severe as in McDonald's spectra. Questions if primordial paucity or destruction via processing, distinguishing birth from voyage. Origins remain probabilistic. Kinematic backtracks to thick disk. Probabilistic, no-source star pinned amid chaotic eons. Future astrometry might refine, but galactic turbulence limits definitiveness. Comparative planetology beckons. How does 3I Atlas's chemistry mirror unusual solar comets like 2016 R2? Shared mechanisms explaining anomalies. Data gaps loom. Mars orbiters on October 3rd offering spatial resolution for coma mapping. Psyche's potential September 4th flyby, and Jupiter icy moons explorer observations in November probing structure. These windows, fleeting as the comet's visit, represent final chances before outbound fade. No returns for interstellar transients. The Rubin Observatory's legacy survey of space and time, ramping to full operations in 2026, heralds a deluge conservative estimates of dozens interstellar objects yearly. Some models hundreds, transforming singleton studies to population analytics. Will this flood unveil carbon dioxide enrichment as thick disk hallmark? Or 3I Atlas an outlier? Carbon chain depletions correlating with age, or metal ratios with origins? Conspiracies brew. Rubin's detections as torrent of extraterrestrial artifacts. Hidden probes amid naturals. A galactic armada unmasked. Spacecraft concepts evolve. Eubanks's multi-platform strategy coordinating. Psyche's September flyby. Mars orbiters on October 3rd. Jupiter Icy Moons Explorer. On November 4th, Lessons for Intercepting Futures. Like Southwest Research Institute's proposals for chase missions, astrobiology implications tantalize. Exotic chemistry is blueprint for alien life. Carbon dioxide worlds hosting chemosynthesizers. Sulfur from carbonyl sulfide. Cycling in subsurface realms. Technosignature strategies refine. White papers defining protocols to spot anomalies amid normals. Avoiding biases. 3i Atlas's lessons in distinguishing weird naturals from crafted signals. Pipelines accelerate for Rubin's flood. Automated spectroscopy, classifying compositions swiftly. Public outreach, emphasizing wonder over fear. Interstellar objects, as galactic envoys, enabling comparative planetology without voyages. 3i Atlas's legacy endures. A catalyst reshaping fields. Galactic chemical evolution through population stats. Planetary formation via ancient samples. Astrobiology via exotic volatiles. Fundamental physics if anomalies deepen. As it departs post-perihelion, techniques honed rapid targeting. Multi-wavelength coordination arm us for the influx. The universe's messengers arriving in waves, yet enigmas whisper. If Rubin's deluge uncovers patterns, alignments, chemical codes, what if artifacts lurk? Mars-flyby testing relics of nuked pasts. Brandenburg's thermonuclear scars on Mars as draw for probes. Historical secrets like Younger Dryas. Impacts, Atlantis's fall, echo comets as destroyers or seeders. 3i Atlas, a sibling probing for survivors. Conspiracies envision flood as ET unveiling. Artifacts mimicking comets, public communication, veiling truths. The cosmos beckons with these threads. 3i Atlas, a harbinger of revelations. It's DSAN, a bridge to futures where mysteries unfold in starlight's embrace. Each discovery a step into the unknown. If these cosmic whispers have captivated you as much as they have me, consider subscribing and turning on notifications. It's a serene way to join more journeys through the mysteries that lull us into wonder. Or share your thoughts in the comments. What do you think awaits in Rubin's flood?